Seminar on multithreading with Aneka. Aneka is a software platform for developing cloud computing applications. It is a pure PaaS solution for cloud computing, and it is a cloud middleware product that can be deployed on a heterogeneous set of resources. The framework provides both middleware for managing and scaling distributed applications and an extensible set of APIs for developing them. Moving further, multithreading with Aneka. As applications become increasingly complex, there is greater demand for computational power that can be delivered by a single multicore machine. Oftenly, this demand cannot be addressed with the computing capacity of single machine. It is the necessary to leverage distributed infrastructure such as clouds. Aneka, as a middleware for managing clusters, grids and clouds, provides developers with advanced capabilities for implementing distributed applications. The amount of effort required to convert an application often depends on the facilities offered by the middleware managing the distributed infrastructure. Introducing the thread programming model. Aneka offers the capability of implementing multi-threaded applications over the cloud by means of the thread programming model. This model introduces the abstraction of distributed thread, also called Aneka thread, which mimic the behavior of local threads but executes over a distributed infrastructure. Thread programming model has been designed to transparently port high throughput multi-threaded parallel applications over a distributed infrastructure, and it also provides the best advantage in the case of embarrassingly parallel applications. Thread programming model. The application is designed as a collection of threads, the collection execution of which represents the application run. Threads are transparently moved and remotely executed, while developers control them from local objects that act like proxies of the remote threads. The thread programming model exhibits APIs that mimic the ones exposed by .NET base class. The system.threading.thread class introduced the Aneka application. There are three major elements that constitute the objects model of application based on the thread programming model. Application, threads, thread manager. Application is the class that represents the interface to the Aneka middleware, and it constitutes a local view of distributed application. Threads represent the main abstraction of the model and constitute the building block of the distributed application. The thread manager is an internal component that is used to keep track of the execution of distributed threads, and it also provides feedback to the application. The Aneka application class provides support for files which are automatically and transparently moved in the distributed environment. As we see in the diagram, the main thread is divided into three threads. Thread 1, 2, 3 initially starts from the main thread. The gap between two threads is threads may switch or exchange data or execution. The execution flow direction is from main thread to the What is the difference between Aneka thread versus common thread? To efficiently run on a distributed infrastructure, Aneka threads have certain limitations compared to local threads. The .NET threading API, system.threading, here Aneka.threading, thread, Aneka thread, and as we see thread.sleep, thread.interrupt, thread.suspend, thread.resume. These are not present in the Aneka. So these are the main limitations of Aneka. The first difference is interface compatibility. The Aneka thread class exposes almost all the same interface as a system. Threading.thread class with the exception of a few operations that are not supported. Interface compatibility between Aneka threading API and the base class library allow quick porting of most of the local multi-threaded applications to Aneka by simply replacing the class names and modifying the thread constructors. The next difference is thread life cycle. In the given figure, the white balloons in the figure indicate states that do not have a corresponding mapping on the other life cycle. The shaded balloons indicate the common states. In most cases, the normal state transition will resemble the one occurring from the local threads. The flow is from unstarted to started, started to queued, queued to running, to completed, to or aborted or failed. It starts from the unstarted, then it moves to the started, it will wait in a queue, it will start running. Once it completed, either it will complete, other abort or else fail. Another difference is thread synchronization. Aneka provides minimal support for thread synchronization that is limited to the implementation of the join operation for thread abstraction. By just designing Aneka threads that does not feature any synchronization facility that goes beyond the simple join operation. Next difference is thread priorities. The system.threading.thread class supports thread priorities where the scheduling priority can be one selected from one of the values of the thread priority enumeration, that is from highest, above normal, normal, below normal or the lowest. These are the priorities. Next difference is type serialization. Aneka threads are distributed and execute on remote computing nodes, and this implies that the object code related to the method to be executed within a thread needs to be transferred over the network. Programming applications with Aneka threads. Aneka threads application model. The thread programming model is a programming model in which the programmer creates the units of work as Aneka threads. Therefore, this is very much necessary to utilize the Aneka application by using WM class, which is the application reference class for all the programming models falling into this category. The Aneka APIs make strong use of generics and characterize the support given to different programming models through template specialization. Hence, to develop distributed applications with Aneka, it is necessary to specialize the template type as follows. Aneka application, Aneka thread, thread manager. This will be class type for all the distributed applications that use the thread programming model. These two types are defined in the Aneka.threading namespace and threading.dll library of the Aneka DDK. Another important component of application model is the configuration class, which is defined in the Aneka.entity namespace. Here is a code for application creation and configuration. How the thread is created and executed is shown in this following program. Here new thread start refers to creating a new thread and thread.start refers to when it is finally created, then it starts to do execution. Domain decomposition matrix multiplication. The class has been tagged with the serializable attribute and extended with the methods required to implement custom serialization. Supporting this custom serialization implies the following: including the system.runtime.serialization namespace. Next is implementing the iSerializable interface. This interface mainly has only one method, that is void getObjectData serialization info streaming context, and it is known when the runtime needs to serialize the instance. Providing this constructor with the following signature: scalar product serialization info streaming context. This constructor is invoked when the instance is deserialized. The serialization info class has a central role of providing a repository where all the properties defining the serialized format of a class can be stored and can also be referenced by the name. There is only one important change to note, that is, once the Aneka thread instance is completed, the updated is reference to the object containing the remotely executed method that is exposed by the Aneka thread.target property and not the local variable referencing the object that was initially used to create the delegate. To leverage such capability, it is necessary that all the properties defining the state of an instance are accessible through both the get and set methods. In such a case, it would be possible to simply tag the class as serialization, since all the fields constituting the state of the instance are also serializable. The next and main step is to change the matrix product class to leverage Aneka threads. We need first create a properly configured application and then substitute the occurrences of the system.threading.thread class with Aneka.threading.thread. The changes that need to be applied to the logic of a program are very much minimal, and most of the modifications are related to exception management and the proper use of Aneka logging facilities. Functional decomposition, that is sine, cosine and tangent. Functional decomposition is a method of analysis that dissects a complex process in order to examine its individual elements. There is only one significant difference in this case. Each of the threads has a reference to a delegate that is used to update the global sum at the end of the computation. This prevents the global sum from being updated in the master thread and requires a change in the update strategy utilized. To allow the execution of such applications with Aneka threads, it is necessary to extrapolate the update logic from the worker method of the threads and perform it into a master thread. Thank you.